In this video, we'll get an introduction to assembly modeling. After completing this step, you'll be able to create a component, create a joint, edit a joint limit, and drive a joint. In Fusion 360, we want to get started with the supplied dataset, reciprocating saw motion. This dataset has two components in it, internal mechanics and saw handle casing. In addition, when we take a look under internal mechanics, you'll notice that there are a lot of other components in here. We also have a bodies folder, which contains a single body for the trigger. Let's take a look at what makes an assembly and what we need to do when we're considering modeling with assembly techniques. The first thing to note is the difference between a body and a component. A body is based on the origin at the top level of the design. Body is fixed in space and can only be moved if you use the move copy or align dialogues. This means that it's not able to be a part of assembly motion. When we take a look at components, for example, the gear housing is a component which houses its own origin. If we turn the origin on, we can see it here, and if we grab this component and move it, note that the origin moves with it. In Fusion 360, we can capture its position, or we can revert it back to its original position. The important thing to note here is that Fusion keeps track of the origin of each component in relation to the origin at the top level of the design. In order for that to be true of our trigger, we need to turn it into a component. There are a couple different ways that this can happen. When we're modeling, at the very beginning of a design, we can start a new empty component. The new empty component can be standard or sheet metal, and the new empty component can be internal to the current design or external, meaning it has an external reference. If it's internal, it needs to note that it has a parent. Now, by default, the parent will be whichever component is currently active. In this case, it's the very top level of our design. We say OK. What we've done is we've created a new empty component. This means that we can start to create sketches. We can start to extrude those sketches into solid geometry. And now our component contains a body, it has its own origin, and it can move around inside of our design. In this instance, we don't actually need this body or this sketch, but we can use this component. Another thing that we can do is we can turn a body into a component. This can be done from the new component menu, or we can simply right-click on the body and select Create Components from Bodies. Now we have a body inside of a component, and this is free to move around because it now has its own origin that Fusion keeps track of in relation to the default origin. Notice how it moves around, and if we turn on the default origin in Fusion, it's at about the center of our design, which is exactly where the origin is for the trigger when it's not moved. Remember that when we are dealing with components, there are some benefits. If we were to activate the trigger, everything else changes opacity. This allows us to get focus on the component or the body that we're dealing with. We can also very quickly and easily isolate it or unisolate it. But one of the main benefits of working with components is the ability to create assembly motion. It's the ability to create exploded views in the animation workspace. And there are some added benefits when we get to detailed drawings. So now that we have a basic understanding of the component structure in Fusion 360, let's talk about ways in which we can begin to create some assembly motion. To get started, I'm going to move the trigger, and I want to align it with this component, allowing them to move together how they should. What I need to do from here is I need to make sure that this component doesn't move in 3D space. In order to do that, I'm going to select the trigger, right-click, and ground it. If I ground it, notice that it still is able to move around. And that's because this is actually a component that has multiple subcomponents, a trigger box and a trigger collar. When we ground the top level, that means that its origin is fixed, But each of these subcomponents are not fixed on their own. What we can do is we can ground each of those, or we can make them rigid groups. For right now, let's go ahead and just ground them, as we'll be talking about rigid groups in another video. Now that all three are grounded, it's fixed in 3D space. What I can do now is begin to align the two components together. I'm going to revert position, and I'm going to talk about how we can align these two. Right now, they're at a different angle and they're at a different position. I'm going to move the trigger and capture its position. Then I'm going to use modify and align. I want to align the back face of my trigger with the front face of this trigger. Notice when I do that, it moves the trigger into position. However, it's not in exact alignment. The reason it's not in exact alignment is because it simply moves to the closest orientation. Let's go ahead and deselect those, and let's look at other ways in which we can align these. If I want, I can take the bottom center of this face and align it with the bottom center of this face. Once the cursor is hovering over something, we can hold down the Control or Command key to lock its focus. Once I have those two aligned, that's the correct orientation. I can capture its position and say OK. Now that it's in position, that doesn't mean that it can't move around. We still haven't told Fusion 360 how we expect it all to move. What we do have is the correct position, which means that we can go to Assemble and create an as-built joint. I want to create a slider joint between these two components. The slider joint is going to mean that it can move in and out based on a selected reference. Now that it can move in and out, I can slide the trigger in and out based on that joint that I gave it. What I need to do now is I need to tell it how much it's free to move. In order to do that, I need to find the joint in the Joints folder. I'm going to rename slider 1 to Trigger Slide, and then I'm going to right-click and I want to edit its limits. I can determine a minimum and a maximum value that I want it to move. Let's say I want it to move a maximum of 1 millimeter out and a minimum of -2 millimeters. Now the trigger can only move a small amount. This is a bit more realistic. One thing that we should note, however, is that the position is not correct. We need to go back and we need to unground the trigger itself, the trigger box, and the trigger box collar. Notice that with those ungrounded, everything moves together as one. What I need to do now is I need to take the trigger box, and the trigger box collar, and I need to rotate them. So I'm going to use the Move dialog box with components selected, and I want to rotate them based on a reference. I'm going to use this circular reference here, and I'm just going to rotate them slightly into position. I'm going to capture its position and say OK. From here, I can then select each of those, and I can reground them. Now the trigger joint should still work just fine. It still moves out 1 millimeter and back in 2 millimeters, but now the trigger is in a better position. It's also important to note that every time we do this, Fusion is keeping track. Every time we ground or unground a component, or move it or capture its position, Fusion 360 keeps a record of this. So in terms of best modeling practices, it's better to model everything in position, and then we can create rigid groups, lock everything together, and then we can use our joints to create that mechanical motion. At this point, we've done a basic introduction to the assembly structure. There's more that we can do with this design by creating the reciprocating motion. But at this point, let's make sure that we do save before moving on.